Let us start discussing few problems related to velocity, acceleration, and distance. So let us start. The time variation of the position of a particle in a rectilinear motion. See, rectilinear in the sense the word rectilinear indicates it is a straight line. Okay, the motion which is going to happen was a straight line motion. So hereafter, whenever you go through this word rectilinear, it indicates it's a straight line motion. Okay, so they given time variation, that is how distance or how the displacement is varying with respect to time, that has been given. Okay, and they said that v is the velocity, a is the acceleration of the particle in a consistent units. Okay, so v will be having the corresponding unit, that is meter per second. This will be having meter per second square. So both of them, that is velocity and acceleration, both will have its units. And now they are asking the motion started with dash. So what is this word indicates? Motion started with means what? What they are saying? They are asking us to find out the initial conditions. Okay, initial conditions means what? They are asking us to find out what is v naught and what is a naught. Okay, when the motion is started, what is going to be the velocity and what is going to be the acceleration. Okay, initially when motion is starting, what will be time taken? Time taken is going to be 0, right? It's very obvious, right? So they given x value. So how to find out velocity? Velocity is nothing but rate of change of displacement. In this case, displacement is something which they given it as x. So what I will do, instead of writing it as x, sorry, s, I will be writing it as x. Okay, so dx by dt, so which is going to be equal to d by dt of 2t cube plus t square plus 2t. Okay, so that is going to be equal to, the differentiation of this will be 6t square, that is 3 into 2 will become 6, and this is going to be 2t plus 2. Okay, this is velocity. And similarly, acceleration is nothing but dv by dt, as we know already. So d by dt of 6t square plus 2t plus 2. Okay, so that is going to be equal to, differentiation of 6t square was 12t plus 2. Okay, now what actually they are asking? They are asking us to find out v naught, right? Which means at t is equal to 0. So when I substitute t is equal to 0 here, velocity will become 2. And similarly we need to find out acceleration. Similarly we need to find out acceleration. Acceleration, how can I find out? Simple, a naught at t is equal to 0. Okay, that is going to be equal to, when wherever time is there, you substitute 0, so this becomes 0. So 0 plus 2, which is 2 again. Okay, so correct answer is both velocity and acceleration was 2, which is nothing but option D. Okay, so let us proceed for the next question. A particle moves in a straight line and its position is defined by the equation x is equal to 6t square minus t cube, where t is expressed in seconds and x is in meters. The maximum velocity during the motion. So they are asking v max. Okay, maximum velocity. How to find out? Just think how to find out maximum velocity. You have to recollect a concept from engineering mathematics. For finding out maximum velocity, we will differentiate, that is generally we will differentiate, suppose function, we will differentiate f of x with respect to x and we will equate to 0 for finding out maximum f of x. Okay, that is for finding out f max. This concept we discussed in detail in maxima minima concept in our engineering mathematics course itself. Now coming to this case, for finding out v max, I need to differentiate v, okay, with respect to variable. And here what is the variable? Variable is time, right? Because velocity is a function of time. Okay, velocity is a function of time. Generally, y will be function of x. So I will be differentiating y with respect to x and I will be equating it to 0 for finding out maxima value. Here velocity is a function of time. So I will differentiate velocity with respect to time and I will equate it to 0 for finding out my maximum velocity. Okay, so first let us start with x is given. So velocity will be equal to what? Differentiation of x with respect to time. So that is going to be 12t minus 3t square. Okay. Now again differentiate this velocity with respect to time. That is going to be 12 minus 6t. After differentiating, equate it to 0. Why I am equating it to 0? Because this is maxima minima condition. Okay, this is maxima minima condition. By equating it to 0, what I will get? I will get critical points. I hope you remember this. So by equating it to 0, 12 will be equal to 60, which implies t is equal to 2 seconds. Okay. T is 2 seconds, fine. But we need to check whether it is maxima or minima, right? See, anyways, we got only one answer one time. So this will be corresponding to maxima only because they are asking maximum velocity. But anyways, let us check. Okay, let us check. For checking, okay, for checking what I need to do. Again, differentiate this velocity. If I do that, it becomes minus 6 because 12 is 0. Differentiation of minus 60 is minus 6 and that is less than 0. If it is less than 0, it is indicating it's a condition for maxima. Okay, so if it is maxima, then time t is equal to 2 seconds indicates maxima. So t is equal to 2 seconds is the maxima condition. Okay, so what I will do, I will substitute this back in our velocity equation, that is this equation. Okay, so V max will be equal to 12 times of 2 minus 3 times of 2 square, which is 24 minus 12, which is nothing but 12. So option B is correct answer. Okay, the next question. The motion of a particle is defined by the relation x is equal to 8t cube minus 8 plus 30 cos pi t. Okay, so this is the displacement which they given. Okay, x is expressed in mm and t is in second. They are asking acceleration of the particle at 5 seconds. Very simple question in fact. First I will find out velocity. Velocity is nothing but differentiation of x with respect to t. So it becomes 24, yeah, 24 t square minus 8's differentiation anyways it is 1 and 30 cos pi t, right? So 30 cos differentiation is going to be minus, it is plus in fact, here it is plus. Cos differentiation is anyways minus sine pi t into differentiation of pi t is going to be pi again. Okay, so that is going to be 24 t square minus 30 pi sine pi t. Okay, and now again I have to differentiate it because they are asking acceleration, right? So acceleration is nothing but 2 times of differentiation of the displacement or 1 times of differentiation of velocity. So if I do that, 48t minus 30 pi will be there, again differentiation of sine into cos, sine differentiation will be cos, and pi t's differentiation is going to be pi. Okay, so finally what I will get, my acceleration final formula or final equation, 48t minus 30 pi square into cos pi t. Okay, so this is going to be our acceleration final formula. And now they are asking acceleration at what? They are asking acceleration corresponding to time is equal to 5 seconds, right? So wherever time is there, substitute 5. So 48 into 5 minus 38 pi square cos 5, sorry, cos cos pi into 5. Okay, which is nothing but cos 5 pi, no issues. So 48 into 5, you can just use your calculator, find it. It will be 240 minus 30 pi square cos pi pi, okay, which is nothing but cos pi, right? By cyclic rule, we can say, okay, I hope you remember these things. Okay, I'm not going to explain to you, but corresponding to pi, I will be getting minus 1. Okay, so cos 5 pi and cos pi will be same. So cos pi is going to be minus 1. Now do the calculation, and if you do it, you will be getting 536 mm per second square because it is acceleration, right? So the correct answer was option D. Okay, option D, 536 per second square. Right, let us go for the next question. Velocity of a particle moving along x-axis is defined by v is equal to kx cube minus 4x square plus 6x, where v is in meter per second, x is in meter, and k is a constant. Okay. If k is equal to 1, the value of acceleration when x is equal to 2 meter would be dash. Listen, this is a good question. See, generally, if velocity was in terms of function of time, it becomes very simple for us. I will differentiate velocity with respect to time. That will be my acceleration. No issues at all. But here velocity was a function of x. We know that x will be function of time, but they didn't given this. They didn't given this. This as being this was given. Okay. So what I can do? I need to use the concept of total derivative here. Okay, I explained about this total derivative concept in engineering mathematics, and even when we are discussing fluid mechanics that time also. Anyways, let us discuss it. Okay, acceleration will be equal to, I will differentiate this velocity with respect to x. Okay, later on I will differentiate x with respect to time, and then if I multiply them I will get the acceleration. In fact it will have three terms, that is with respect to x, with respect to y, and with respect to z. But anyways, we are dealing only with x, right? That is, we are dealing only with rectilinear motions. Okay, so only x will be there. So first let me differentiate what is that velocity with respect to x. So if I do that, what will happen? K into 3x square, right? Because k is a constant, minus 8x plus differentiation of 6x was 6 into dx by dt. Okay, so this will be my acceleration. Now what is this dx by dt? Okay, we already know, right? V is nothing but dx by dt. Rate of change of displacement is velocity. So k 3x square minus 8x plus 6 into velocity. Okay, now they are asking at 2 meters. So first let me find out velocity. Okay, let me find out velocity at 2 meters. Okay, so if I substitute x is equal to 2 here, and also they given k is equal to 1. Okay, so 1 into 2 meter minus 4 into 2 square plus 6 into 2. So that is going to be, this is going to be 8 minus this is going to be 4 plus 12, which will be equal to, this is 16, and it becomes minus 8, it becomes finally 4. So velocity at 2 meters was 4 meter per second. So we determined velocity. Now I need to find out acceleration. Let me use another color here. Acceleration corresponding to x is equal to 2 meters. We know that k is equal to 1 already, right? So 3 into x is 2 meters, so 2 square, minus 8 into 2 plus 6, okay, into velocity, which is going to be 4. Okay, and now simply just do the calculation. I'm not going to stuck up with this, and then just do the calculation. If you do it, you will be ending up with 8 meter per second square, which is option A. Okay.